Hello everyone. Just wait for 1 minute, see if others are joining, and then we'll give it a start.
Hello.
Hi Rohi. Not sure if anyone else is joining in the right now. Maybe they will fall in. So what I'll do, let me share my screen and let's go ahead. So most probably we will be going through the calculations today also. So let's see if we are able to complete it within the first half an hour. Then we'll continue with some coding, right? So for coding, most probably I'll use some other data because I tried to download this data, I couldn't get it. So one way will be that I'll take this data and put it into a CSV file. That's one way. So we can try that. But first, let's check the calculation. So the main idea, as we were discussing earlier, is that we have to find out what is going to be our suitable root node, right? And to find the suitable root node, we make use of the calculations of entropy. We make use of the calculations of information gain. And then we try to repeat this exercise until we have got the pure tree, right? Now, one thing that I did not specifically mention in the last session also is something related to how entropy also, or how, let's say, information gain and entropy combination also helps us do the determination of which is going to be the root node. That was not specifically told by me because that's better if we do a calculation and then we will be able to look at things, right? So let's go ahead with the calculations and then we'll understand how entropy and information gain will help. So what I'm going to write over here is the column name. So I'll start with Outlook first, then we will go to the other columns one after the other, right? So I will just draw one block first and then I'm going to do copy paste, right? So in this block, what I'm going to do, I'll write the values of Outlook. So the values of Outlook is what, these three. So I'll just take a copy paste from here. Then basis this value, okay, basis this value, I'll either play or I will not play, right? That is the point here. So I will either play or I will not play. So these two form, let's say, let me just do this merge and center, and I'm going to call this play, right? So that's the name of the column. It can either be yes or no. Outlook can be any of these three, right? Let me quickly check what Sarang is saying. Uh, okay, let's try to continue. Now what we are going to do is that then we are going to have a total column. Okay, you will understand why we are taking a total column. It will be absolutely clear once we do the calculation. Okay. So what I'm going to do now is that I'm going to just mark all of these in bold. Okay, I'm going to mark all of them in bold because now what I'm going to do is that I'm going to draw this as a table. Okay, later on I'm just going to do copy paste. So I'm just making my life easy. Now I will do some calculations here. Now these calculations will be very rudimentary. So let's do it quickly. So if you look at the data, if you look at the data for Outlook being overcast, okay, Outlook being overcast, play is every day, right? Play is every day. So we have 4 yes, right? We have 4 yes and 0 no, right? In this way, I'm going to do the calculation. So now this total here, okay, this total here is going to be sum of this, and this total here, okay, is going to be sum of all of these, which should finally match up to 14. And obviously the sum over here will also match this total. So I'm going to say this is going to be a sum of these three, and then this is going to be a sum of these three, right? So this is going to continue for all of the features. So we have 4 features. We are going to do this exercise for all of the 4, and then we are going to calculate some of the probabilities. These will be individual probabilities. These will be individual probabilities, and then there will be conditional probability, right? So individual probability, I'm going to call that P of outlook, right? Because we are talking about outlook here. So I'm actually talking about probability of outlook or the type of outlook. So this field is going to have, the sales are going to have the probability of this kind of outlook, right? So that is what we are going to calculate. Okay, later on what we are going to calculate, probability of play given a certain value of outlook. Okay, then we are going to calculate probability of no play given a certain value of outlook, right? Then we are going to finally calculate entropy. Okay, entropy of play given outlook. Okay, now from this entropy we will get the information gain. Oh, sorry, I did a spelling mistake. Now what I'm going to do, let me just expand, right? Now we are going to do the calculations here. We will do the calculations here. So let me just put them in blocks, and then I'll go to the right side. Maybe I'll just zoom out a little bit. Rohi, can you confirm if you are able to see it still, or maybe I should do a deletion?
Yes, I can see it.
You can see it, right? The zoom is fine.
Yes.
Okay. Okay. Good. Then let's calculate the numbers first, and then we are going to go. So because you have understood what we are doing over here, I'll go a little bit quickly, maybe, right? So for rainy, what I have, yeah, okay. For rainy, I have 3 2, right? And I did not scroll this down. Okay. For rainy, I have 3 and 2. For sunny, what do I have? 2 3. Very good. So I have 2, I have 3, right? So this is the division. Now what I'm going to do in this case, in this calculation, okay, in this calculation, what I'm going to do is that I need the probability of each type of outlook. Okay, so how can I calculate that? This can be equal to, or this can be said to be equal to E of cell E26. Okay, so that's the total number of overcast outlooks divided by, ignore the dollar sign that I'm going to use, because that's a specific property that is related to Excel. I'll explain that to you also. So the probability of outlook being overcast in our data, in our total data, probability of outlook being overcast is 4 divided by the total number, right? Then the probability of rainy will be 5 divided by the total number. So if I do a drag and drop of this formula, right, the formula will not change, you see, because I have given a dollar, because I have actually given a dollar, it does not change. If I didn't give a dollar, right, it would have changed it. It would have replaced E29 with E30. So that is the reason why I give a dollar. Now, obviously, okay, obviously this sum is going to total to what? This is going to total to 1, right? Because this is individual probability, right? Individual probability always zeroes down to 1. We know that already, right? So that is just a confirmation that we have calculated the probabilities in the right way. Now let's try to calculate the conditional probabilities. Okay, now we are going to calculate the conditional probability. So if you remember what we discussed in the days of conditional probability is that we have some event which has already happened, right? We have some event which has already happened. Give me 1 minute. Give me 1 minute. Huh? Okay. Yeah. So in case of conditional probability, how we do the calculation in very, very simple words, okay, is that what we are going to do? We are going to take uh, the probability of play, which in this case is going to be this value, right? So probability of play by output is going to be this number, okay, this number by the total number. So it is going to be this divided by this, right? Yes, this divided by this. So if I continue doing this, right, then this is what I get, right? The calculations are fine. Obviously this is where the sum is not going to match over to 1. This is something that we need to remember. Conditional probability, okay, conditional probability does not add up to 1. So this is a property of the conditional probability. That's the reason why even if you do a sum over here, right, it may not really add up to 1. So it doesn't matter whether it adds up to 1 or not, but it uh, may not add up to 1. So here if you see, the addition is going to be equal to 2. Right? If I just extend this formula from here to here, you see the total is 2. So this is completely fine. Okay, regular probabilities will add up to 1. Conditional may not really add up to 1, which is okay. Now I do the same thing for no play. So for no play, what is going to happen? This divided by this, right? So the probability of no play given the outlook being overcast, how many times did I play? 0. So that's why it is 0 divided by 4. Next one is 2 divided by 5. Next one is 3 divided by 5. So this is what I get, right? The basis this, okay, basis this, I'm going to calculate the entropy, right? Now this calculation is going to be difficult, right? And before I do that, okay, before I do that, I'm going to explain you. Uh, Give me 1 minute. Okay, yeah. Sorry, Rohi, I was actually getting a chat in one more window which I had to attend. Now let's calculate the entropy. Now to calculate the entropy, uh, what we are going to do is that we will need to uh, look at the formula. Okay, first of all, we need to look at the formula. What is really, or how do we define entropy, right? Now to do that, what I will do is that I'm not going to calculate that formula. I'm actually go over to Wikipedia. I'm actually going over to Wikipedia, and from there I'm going to calculate the formula, or I'm going to get the formula so that I can simply show you how the calculation has to be done. Okay, how the calculation will be done, right? How the calculation should be done. So let me just open the formula for you. So I'm just uh, zooming out my page, and then I'm going to do a new share, and then I will share this page with you now. So as you can see on my screen, this is a website. I'll share this website also. This is a very good website actually. So I'll share this to all of us on the chat window. And what we are seeing over here, okay, what we are seeing over here is that this is the formula that I have for entropy. Okay, so this is the mathematical formula, the way in which we define the formula of how to calculate entropy. So what we are doing over here is minus p multiplied by log base 2 of p. So we are going to call this log. It is not a natural log. A natural log is a log base 10. So we are going to call this log base of 2, or you can simply call it logarithm, right? So logarithm, okay, logarithm of p multiplied by minus p minus q multiplied by logarithm of q. Now the question is, what is this p and what is this q? This p over here and this q over here represents the classes in your data. So for example, in our class, right, in our case, in our data, we have two classes. We have yes and we have no, right? So these numbers here, okay, these numbers here actually represent the probability of yes class and probability of no class, right? Now this entropy has to be calculated for the entire data set, and to do that, what we need to do is that we have to calculate it for all the features. For example, I have 3 features in my data, or I have 4 features in my data, okay, I have to calculate it for all the features. Okay, now the problem is, if I'm going to calculate it for each and every feature, and let's say all of these features, let's say in my case, okay, my case is a very, very difficult case where each and every feature is actually a categorical feature. Okay, so each and every feature can have two values or three values. So for example, in my case, Outlook can have three values. Okay, temperature can have two values, and so on and so forth. So in this case, what do I do? What I have to do is that for each and every value of these features, I'll have to calculate the entropy using this formula. So using this formula, I'll have to calculate the entropy for each and every value. Okay, for each and every value or each and every class, okay, or a type of output for each and every feature in my data. And then what I'm going to do, I'm going to calculate the entropy for each feature, right? Then I'm going to do the calculation of entropy for each and every feature. From here, I will come to know which of these features, for example, which is that feature f of x, fx, okay, which is that feature fx, which has, okay, the lowest impurity. Okay, now this impurity thing, as I said earlier, impurity is defined by what? Impurity is actually defined by the entropy measure itself. But what we are going to do, we are going to calculate the information gain also, right? So we are going to calculate the information gain also, but we can see it from the entropy value also. So for example, for each and every features, I have got, let's say, the entropy value. And for example, for feature number 2, okay, the entropy value is 0.4, right? For every other feature, f1, f2, f3, and f4. So for f1, f2, f3, and f4, out of these four, f2 has this value. For 1, 3, and 4, the values that I've got are actually greater than 0.4, are actually greater than 0.4, in which case I can say that the entropy of F2 is the minimal, right? Entropy of F2 is the minimum. So that's the reason why I'm going to choose F2 as my feature, which becomes my root node, right? Now, obviously, or you can say conversely, okay, obviously, or maybe conversely, because this feature F2 has low entropy, right? You should have already guessed the answer by now. It will have what? High information gain, right? So whatever has lower error, right, or whatever feature has lower impurity, I should not use the word error actually, that was wrong of me. I should use the word specifically as entropy, because error is going to mean something entirely different. I'm sorry for that. So in this case, if F2 has the lowest entropy, then it obviously has the highest information gain. That is the reason why we have chosen this feature as the root node. Then we start creating our tree, okay, basis the values, the distinct classes of values F2 can take. Then we get the rest of the features and break them using F1, F3, and F4, and so on and so forth, right? So this is the way what we are going to calculate. So please note the formula. The formula is minus p log 2 of p minus q log 2 q, right? So p is the probability of the positive class, q is the probability of the negative class. In other words, you can say q, the probability of q is actually 1 minus p, right? Because p is the opposite of q, right? So that also we can say. So let's go back to our Excel and let's do the calculation. Right now, this calculation will be difficult. Okay, this is going to be confusing, right? But let's try to do that. And then what we are going to do, we are simply going to copy paste it, right? We are simply going to copy paste this entire block. We are going to copy paste, right? We are entirely going to copy paste this for all of my other features, and we will see for which one my entropy is the lowest. This is the field I'm actually looking for. Let me highlight this in yellow, and this field, I need this value. Let's say this is going to be the total value. I'm going to calculate the total entropy for each and every class, and I'm going to add them, as I said, right? So what I'm going to do, this value over here is going to be a sum of all these things, right? And here I'm going to put my information gain. Okay, information gain is going to be very simple. I will give you the formula of information gain right now. Okay, information gain is really going to be very, very simple. Okay, information gain is actually a byproduct. Okay, it is actually a byproduct of entropy. But before you take the byproduct of entropy, what you do, you have to calculate something. Okay, you have to calculate something which we have not done. So we have to calculate that first. right? We have to calculate that first, and then we can calculate information gain. So let's do one thing. Let's create some cells over here. Okay, before we can calculate information gain, we need to calculate something. So what we have to calculate is, for play having two categories, yes and no. Okay, yes comes 9 times in my data, no comes 5 times in my data. So total plays, okay, becomes 14, right? Total play becomes 14. So I have to compute the individual probability. The individual probability is going to be what? This divided by this, right? If I take this, this is 0.64286. Again, I'm going to take this one is equal to this divided by this, right? The event I'm interested in divided by the total number of outcomes, right? The expected outcome by the total number of outcomes. So I get the probability. Good. Now if I calculate, uh, now if I calculate the entropy, okay, in this case, how am I going to calculate the entropy in this case? I have to calculate the entropy in this case also. Then only I can proceed towards the rest. So this I will do first. I will do first this, because this is going to be the basis, okay, based on which we will be calculating the information gain. Okay, so what I'm going to do over here is, my mouse is behaving very weirdly, not sure why. Okay, so I'm going to calculate the entropy over here. Entropy over here is going to be calculated as, okay, entropy over here is going to be calculated as, this is the entropy of the overall data set. Okay, we are calculating this so that we know the impurity in the overall data set, and then we use this overall data set impurity, okay, which is in cell D26 here. Okay, here we say $D $26, okay, minus my entropy value. Okay, this is going to be my information gain. Why did I use the dollar? Because I'm going to later copy paste the cell, so that's why I will need that calculation. Now to calculate the entropy, what I'm going to do, using the same formula, okay, using the same formula which we saw in that website, if I simplify that formula, what comes out is, okay, what comes out is, if yes is my positive class, if yes is my positive class, right, then I have to take minus of the probability of the positive class, which is this, right, multiplied by logarithm of, in Excel, log formula refers to log base 2. So you can also specify the log, right? So log of, again, this value, log of this value, base 2. This is the formula, right? Minus p log base 2 of p, right? Obviously, this is also going to be the same, right? So let me just drag and drop it over here. Okay, let me see if anything has gone wrong. Probability. Uh, no. I think the drag and drop was not right. Uh, this should be B25, C25. Yes, it is right. Yeah, it is right. I'm sorry, it is right. Now what I do, I have calculated the entropy. So the total entropy is going to be, okay, this plus this, right? So sum of this, comma, this. I hope you understood what I am doing over here. Let me quickly write the formula again. Minus p log of p, okay, minus q multiplied by log of q. So I have calculated this value. This value is here. I have calculated this value, taking the minus also. Taking the minus also, I have calculated the value over here. So I have got one value, I have got the other value. I simply have to add them, I get the final value, right? I get the final value. So clearly my data has good amount of impurity. I can't say that yet. It is just my guess. This is my experience. I'm actually sharing this, but we'll come to know later on. Now I have to use this data. This data I have to use to find the information gain, right? I have not calculated the entropy. That's why the information gain is equal to the entropy of the total data set, right? This is the entropy of the total data set. Now let's calculate the entropy of each and every cell, and we will come to know what is going to be the final outcome, right? Obviously, I don't have to calculate this cell, right? And I will show you why I don't have to calculate. Okay, let's do the calculation and we will come to know. we may not really need to calculate this cell because one of our values is 0. So you will come to know why this affects this to be equal to 0 also, right? But we will also calculate this. We will clearly calculate this. Now to calculate this entropy of play given outlook, okay, give me 1 minute. Give me 1 minute, right? Now this, yeah. Oh, I'm sorry. I think I missed one cell here. Yeah, I have missed one cell. Give me 1 minute. Give me 1 minute. I have to find the entropy of overcast first, right? I have to find the entropy of that feature value. Of that feature value, I have to find, then I can find the entropy of what that feature will have an effect over play or not play. Right. So now entropy for overcast can be calculated what? Minus, okay, minus of this. This is my positive point multiplied by log, okay, of this base 2. Okay. This is one value, okay, and I have to do plus, uh, yes, minus of this value, right? Yes, multiplied by log of h31 base 2, right? This is the end of the first bracket. Then the second bracket ends over here. Okay, log of yes, 31 divided by 2. I've done a plus with this. Okay. Why is that not to making the calculations? Okay,
Yeah, log 0 is infinity.
okay, okay. So let me use another function in Excel, and hopefully this should solve my problem. You have entered. Oh, okay, yes, yes. If error, then 0. Yeah. So yes, I think I think this is the correct way to represent. Yes, I have done the right thing, right? G31, which is my positive. G31 is my positive log of positive base 2 plus minus of negatives probability multiplied by log of this. Yes, I think I have done it correctly. So I'll just extend it like this. Now the entropy of play given outlook. Okay, the entropy of play given outlook, okay, is going to be the probability of outlook, okay, which is this, okay, multiplied by the entropy of that field, right? So that is exactly what is going to be the value. If I just drag and drop it over here, so I get a total value of 0.69 and I get an information gain of this. Okay, it's fine, right? Now, okay, now if I look at this, now, I have calculated the information gain and entropy for 1. Now I have to do it for 3 more. So let me just do it. Yeah. Okay. Now what I will do, in place of outlook, I have what? Temperature, right? And in case of overcast, sunny, I have hot, cool, mild, right? So I'll, hot, cool, mild. I just have to change these values. So everything else should change, right? Everything else should actually change. So for temperature being hot, let me do a data filtration. So why? I can do a calculation also, right? I can look at the data and find out hot is how many? Hot is, yes, 2, 2, right? For hot it is 2 comma 2, right? Then for cool it is mm, hot, cool, mild, right? Yeah. For cool it is what? Cool it is 1, 2, 2, 1, 3, 1, right? It is 3, 1. So where it is 3 comma 1. Obviously this is going to be 4 and this will be 2, right? Because the total has to be 15. Now I have got the impurity here, right? I got the entropy here, I got the information gain here. Again, let's do the same thing over here, right? Now the third feature is going to be what? Third feature is going to be humidity. Okay, humidity. Humidity has how many values? Two values, high and normal. So let me just delete this. Okay, high, normal. Okay, high. How many are there in high? In humidity, how many are there in high? If humidity is high, then I have one yes, two yes, three yes, and four no. Three yes, right? Three yes, four no. Okay, and if it is normal, then I have one, two, three, four, five, six. Six yes. Six yes and one no. Right? So I have six here and one here. Right? I have got the calculation for humidity also. What is the last one? Windy. In windy also I have two values. Let me remove this. I have two values. Windy is what? True and false, right? Yeah. So I'm going to mark two. Oh, sorry, false. Okay. So for true, I think windy being true, yes, yes, 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 3. Good. So 3, 3. Right? If this is 3, 3, then this should be 6 and this should be 2. Right? So I have done the calculations now. I hope you got the point here. Right? I hope you got the point. Maybe we can also hide this part because, oh, shit. Sorry. Rather than hiding, I did a deletion. Fine. I think we have done the calculation. Now you can clearly see where the information gain is highest. The information gain is highest for Outlook, right? Information gain is highest for Outlook, right? And that's the reason why we use Outlook as what? We use Outlook as our root node. And then accordingly, we will be doing the same calculations. Okay, the same calculation that we did over here is going to be repeated. Okay, it is going to be repeated a probability basis, and then it is going to get, let's say, divided. Okay, so the ones which are with lower entropy, absolutely low entropy and maximum information gain, that is going to be used as my root node, and then the process is going to recursively continue. So until this point in time, is there any doubt? Because this main intention of this exercise was just to show you what our algorithm is going to do under the hood. Okay, at least to calculate my root node. So my root node selected is this one. Here is the winner because here I have maximum information that I could gain. Right. Uh, any questions here, Rohi? Meanwhile, I'll see what. Uh,
No questions.
okay, Rohi. Okay. Then let's try to continue with some coding. So what I am going to do, what data can I download? Let me see if I have any data. Give me 1 minute, Rohit. Yeah, let me just stop the sharing because there is no point of showing you that Excel sheet. So let me stop the sharing and let me see. Do I have? Study. Yes, I do have some data. This is not the same data that I used for this example because obviously the data that I used is quite childish. Obviously, you will not do things like that, right? So I let me do one thing. Let me do it with two data sets. We will start with one. I just found two data sets. Okay, let me start with one. I'll just copy that data first. Let me copy that data. Where is that data? Yes, I got this adult data set. This is a very um, I think this data set is for, let me just see what is the use case. Yes, this is for prediction of income. Okay, yeah, this is for the prediction of income. So you might be wondering why we are taking prediction of income being a continuous variable, right? But our question is going to be framed in a different way. So we will come to know what we are doing over here. So let me just go to this folder, open my Jupyter notebook, and it has opened. So I will come over here, and where is my Zoom? Yeah, here it is. Let me share the screen. I hope you can still hear me, right, Rohit?
Yes, I can see
Okay,
also.
okay. Now I will create a page, a new Jupyter notebook, and I'm going to call this decision tree income prediction. So this use case that we are going to look at, okay, is something like this. I have some data, okay, I have some data where uh, in the given data, I can say the salary or income of certain set of people are marked as a category. Okay, it is either, okay, it is marked as a category. So it is either represented as less than or equal to 50,000 or greater than 50,000. Okay, this is what I have to find out, right? This is what I have to find out. And what are the attributes? What are the attributes which we have? Okay, let's first of all give a name to this file of ours, otherwise we will lose it, right? So this is, give me a moment. This is class number 113. Okay, class 113, uh, 23 November 2020, and let's call it decision tree. Right now, I have copied this data, adult dataset.csv. So what I have, okay, in this case, these are the variables which I have. Okay, these are the variables which I have. So I know the variables because I have not really collected the data, but I have worked on this project earlier. So that is why I took this project as an example. So let me just go ahead and tell you what this data really means. Okay, and I'm going to take some examples from the data also, and then we can go ahead and we can see what are going to be my feature variables and what are going to be my target variables. Now, obviously, we are not going to do only decision tree over here. We are going to look at some extra techniques also. Okay, I'm trying to combine. Okay, I'm trying to combine a few things at one go so that we can save the number of days that we need to invest also. So what we will be doing, we may also be looking into the ways of improving the model. So after we have created a base model, we will look at how to improve them. We may use things like cross validation. But let's first understand the data contains the below columns. I believe I've made a spelling mistake over here. Yeah. So age, obviously, age I understand. Working class is what? You see, working class is this one. Okay, working class in some cases it is not there, but in some cases it is going to be private, or it is going to be state government, or it is going to be federal government, and so on. I believe this data belongs to the US. Okay, most probably because it is talking about all these federal government and so on. The third is the final weight. Okay, the FNLWGT. Okay, FNLWGT is something, okay, something that is representing your highest education. You see, highest secondary no, FNLWGT is this number. Sorry, I'm not able to understand what this number means. I will get back to this. Okay, let's get back to this. I'll try to find out what is going to be the definition. Maybe I'll have to look at the data definition file. Uh, the next one is going to FNLWGT. I'll just mark this here. Huh? I'll just mark this as not sure. Okay, we don't know what that field yet is. Next one is the education field. Okay, education field is how much they have studied, and that education field is also given an education number. So that number is the number of years most probably. right? Or kind of a number which is given to represent the level of the education. Then we have the marital status, we have the occupation, then we have the relationship, we have race, white or black or something. And we have the gender of the person, so female and male and so on. Then we have the capital gain. Okay, so the capital gain in many cases I could see zero. I don't know why. So capital gain is something like how much let's say that person has invested and how much they have uh, come up as a gain or how much they have come up as a loss. Okay, how much capital they have gained or how much they have lost. Okay, now the next feature is hours per week. Then the native country. I believe everything is United States, if I'm not wrong. Okay, but we will see. I just saw one entry for Asia Pacific and Vietnam also. Okay, it can be other countries also. And then I have the final target variable, which is given in this format. So it is either less than equal to 50k or it can be greater than 50k. Okay, but we don't know what is this FNLWGT. Give me 1 minute. Let me see from where I took that data. Do I have uh, any data definition in that folder? In that folder from where I took the data. Let's see. No, this seems to be a very simple but just an identification. FNLWGHT, the WGT. Let me just search if I can find this data. Just a moment. Mm, oh, yes, obviously. I thought so. It should be there in Kaggle. Yeah, I thought so. Yes. But is it explained? Yeah, it is explained. Yeah, it is explained. It is explained. What is that continuous variable? That is what I'm asking. Huh? People are not explaining that. I don't know why. So I found these two links. Let me just share them with you. So the first link is this. Okay, this gives us the details of the data. What is the data set? Okay, how many attributes are there? How many columns? How many rows are there? Right? So this is where the data can be downloaded from. And then I found another URL. Okay, with the URL looks something like this. Here they do not tell us what that specific column was. That's the issue. So here they tell us the sources from where they have captured the data and so on and so forth. Then they are giving us some algorithm names. Please don't look at them right now. Okay, please don't look at them right now. We are going to implement the decision trees. Okay, most probably we will be implementing this one. So this is also a decision tree, right? Final weight. In other words, this number of people the census believes the entry represents integer greater than zero. Okay, okay. Let me just open your page here, Rohit. Yeah, the one that you have just shared. I'll just open cancel. Let me just disable my internet download manager. Um, Let me just disable my extensions because otherwise it is trying to download it. So let me just disable it and let me rerun. Cancel. Why is it not doing it? Okay. Huh? Okay. Fine. Go ahead and download it. Go ahead and download and then I will open it. Downloads. Downloads and data modified documents 048. I believe this should be the one. Yeah, this is the one, right? Yes, predicting if income exceeds. Yes, right. You are right. So, final weight. In other words, this is the number of people the census believes the entry represents. Okay, good. Good that you have also found this thing. This is a very handy thing. So, I didn't hide this. Now, what we are going to do is we are going to look at this kind of, let's say, uh, distributions also, but our main objective is to do this. Our main objective is to do this. Now there is clearly one problem that we see over here. Good that you have shared this thing. So for one label, okay, for one label I have one number of data which represents only 25%. The other represents 75% of the data. So there is clearly, okay, clearly there is an imbalance. Okay, such kind of imbalances can be solved. Okay, later on we will see how these kind of imbalances can be solved, but as of now we are not going to look at it. But if you are interested to read about it, how to solve this kind of problem, I'm just going to tell you the name of a technique. Okay, the name of a technique which we can look at a later stage if you want. So the SMOTE, okay, this is a technique. Sorry, just delete this. Hmm, so I'm just going to close and okay. So you can look at this technique. Let me just clear all the drawings. Yeah. So you can look at this technique. This is already there in a website, Machine Learning Mastery. This is a free website. It's a very, very good website. Here you can find out what happens if you are having imbalanced data in case of classification with Python. So that's a good example, but this you can use as a reference, right? Most of the time, this is not really required. The full form of SMOTA is synthetic minority oversampling technique. Okay, if I have a minority class, how do I do resampling or a proper sampling to get a proper output? Right. So we may not be using it in our case, but it is good to know. Okay, it is good to know. So I will remove this not sure thing. Now we know what we are working with. So let's import pandas as PD, or maybe what we can do, Rohi, in the interest of time, let's make a stop here for today. We did not do any coding, I understand, but let's continue from tomorrow. Is that fine? Then what we can do, we can start fresh, right?
Yeah, yeah, that would
Yeah.
be great.
Okay.
So what is
Okay.
this
Fine.
FNL WGTI? I got the definition, but I'm not able to understand the meaning of
No,
this.
even I have a confusion, but what it says is that final weight. In other words, this is the number of people the census believes the entity represents. So, for example, let me just reshare. What I could understand is this. Let me just reshare. Okay. So, in other words, this is the number of people the census believes the entry represents. So, what this means is this entry, for example, okay, the FNL WGT is this. So, whomsoever is representing this entry, okay, is actually representing these many people in that country. Are you getting my point? So, this is the weight of how many people in that country this sample is representative of, right?
Okay, okay.
So that's the weight it is talking about. You see, in other words, there's a number of people the census believes the entry represents,
Hmm.
right?
Okay, that should be.
Or at
Okay,
least
yeah.
that's what I could understand. I mean, looking at the English, this is what I could understand.
Yeah, okay, okay. Sure.
Okay, Rohit, then let's make a stop over here. I'm obviously not going to share this file because we have not done any coding, but I'll share my Excel sheet so that you can play around and then we can continue from tomorrow.
Yeah, okay. Thanks.
Thank you,
Good
Rohit.
night.
Thank you.
Good night.